So this reaction, we have liquid hexane reacting with oxygen to produce CO2 and water. So it's another combustion reaction. So we have hexane, CH3, CH2, or CH3. This is liquid hexane reacting with oxygen gas to produce standard products of a combustion reaction, which is CO2 and H2O. Okay, so if we were going to go through the balancing steps here, we'll need a fractional coefficient to do it easily. What we'll end up with is the coefficients of 2, 19, 12, and 14. So rather large coefficients, but you all can do this. You can do that. And so this is our balance equation. These are the correct coefficients. So now we have the foundation we need to do this stoichiometric problem. So let's check our starting amounts. It says that we are starting with 77.6 grams of hexane and 90.3 grams of oxygen gas. They ask us what's the theoretical yield of water formed. Okay, so we have 77.6 grams of this and 90.3 grams of that. How much of that will we make? And we're going to find that in grams. I don't think it specifies grams or moles. Also, maybe we could report this as moles, but I'm going to go ahead and find it as grams, as a mass. So off the bat, I notice I'm given an amount of this reactant and a specific amount of this reactant. When you are given amounts for both reactants, you need to determine what your limiting reactant is. We're going to find our limiting reactant again by converting from this to that to figure how much water we can make, and then seeing how much water we can make from that given amount of oxygen, and comparing to see which one limits how much water we can form as a product. So I have 77.6 grams of hexane and 90.3 grams of oxygen. We need to first convert from grams to moles so that we can use the mole ratios as a conversion factor. So there are 86.18 grams of hexane in 1 mole of hexane, 32 grams of O2 in 1 mole of O2. So now we have moles of each of our two reactants. So now that I have moles of hexane, let's look at the balance equation to pull the coefficients and the mole ratio that will allow me to convert from moles of this to moles of this. The conversion factor reads as follows. 2 moles of hexane are consumed to produce 14 moles of water. Now, if I stop, I know how many moles of water I can produce from 77.6 grams of hexane. On the same hand, we can do the same thing for water. The balance equation reads 19 moles of oxygen are consumed to produce 14 moles of water. I know how many moles of water I'll make from 90.3 grams of oxygen. But again, let's multiply by one more conversion factor to convert from moles of water to grams of water. 1 mole of water is 18.02 grams. 1 mole is 18.02 grams. So now my units are grams of water, so I know to stop. So let's do the math. 77.6, open parentheses, 1 over 86.18, 14 over 2, 18.02 over 1. I get 113.58 grams of water. Then 90.3 open parentheses, 1 over 32, close. 14 over 19, close. 18.02 over 1. I get 37.47 grams of water. So assuming I did the math correct, what we've done is we've determined how much water I can make from 77.6 grams of hexane. I have enough hexane to make this many grams of water. I have enough oxygen to make this many grams of water. Which one of these reactants, hexane or oxygen, is limiting how much water or how much product we can make in this reaction? That would be the oxygen. I only have enough oxygen to make 37.5 grams of water, while I have enough hexane to make 113.6 grams of water. So this mass of oxygen is our limiting reactant in this reaction. O2 is our limiting, and hexane is our excess. By definition, your limiting reactant is completely consumed in the reaction, and your excess reactant, there will be some left over once the reaction stops. So this 90.3 grams of oxygen, this reaction will go forward. These two will react. The reaction will go forward until all the oxygen is gone. It'll run out first. When there's no more oxygen, the reaction stops, and we won't form any more product. When the reaction stops, we'll have some hexane left over. We can figure out how much, but this right here doesn't tell us. We can determine it, but we can't figure it out from this amount, from this information. Okay, so we won't make 113.6 grams of water because we only have enough oxygen to form 37.5 grams of water. Once we form 37.5 grams of water, the oxygen's gone, the reaction stops. We'll never make this. Even though we have enough hexane to make this, we will never get that much. So to 3 significant digits, 37.5 grams of water is our answer.